In another tutorial, I've demonstrated how you can use Excel to produce a good science graph. In this tutorial, I plan to take things a step further. Many school science qualifications, such as the IB Diploma Programme and A-Level, require that you have an understanding of uncertainty and know how to show uncertainty on a science graph. I'm going to demonstrate how to do that using the data that you have in front of you, the falling paper cones data that I've used elsewhere. If you look at the top of the columns, you'll notice that I have written in a crude way the uncertainty in both the height and the time. The height has been judged to have an uncertainty of plus or minus 2 centimetres and the time plus or minus 0.1 seconds, relating to approximately to human reaction time. First of all, it's worth noting one little thing. If you look at the individual readings in the columns, you'll notice that they are very inconsistent. The height readings are all fine, but the readings that we have for the time are displayed to varying numbers of decimal places, and this is something that you could be penalised for if you publish this in your coursework. As a general rule, the number of decimal places that you should give should be no greater than the number of decimal places used for your uncertainty. Since my uncertainty is given to one decimal place, it's therefore logical that each of my readings and the average are given to the same number of decimal places. To change this, I'm going to highlight the affected squares. If we right-click on the squares, we bring up a few options, and I want to select Format Cells, and then from Format Cells, if I select the Number tab at the top, and then select number, we can alter how many decimal places to display, and in this case I just want to display 1, and if I click OK, it alters the data accordingly. In doing this, it hasn't actually rounded up or rounded down the values. The values that Excel is using to calculate averages are still the same, and likewise the value it will plot on the graph is still the same. It's just altering the way in which it displays it in the table. This, however, is fine as far as coursework is concerned. Now I'm going to go to my chart. This is the chart that we learned how to plot in a previous tutorial. At the moment, there is no indication of uncertainty in this chart. I can add uncertainties by clicking on one of the points. If I do a right click, it brings up a menu. I want to select Format Data Series. Now, there are a number of options available here. If you look at the top, there is the option to display X error bars and also Y error bars, and it's those that I want to start with. My Y errors are actually quite small here. In total, the Y error bars are plus or minus 2 centimetres. Now, there are various different types of errors that I can display in Excel. At the moment, you'll see it's selected fixed value, but I could also choose a percentage error if my error existed as a percentage rather than a fixed value. Here, fixed value, however, is appropriate. What I want to do is change the plus or minus 50 to 2, and then I need to tell Excel to display both error bars. Previously, it had been set to display none. If I click OK, you'll notice that there are some very, very small error bars now plotted. If the error bars got much smaller than this, it wouldn't be worth actually displaying them, but it would be worth putting a comment somewhere in your work quoting the fact that they were too small to be displayed on the graph. Let's go back and add our X error bars. So this time I'm going to click on X error bars. I'm going to select both, and once again we're going to use a fixed percentage. This time the fixed percentage was deemed to be plus or minus 0.1. If I OK that, you'll now see that I've got much bigger error bars in the X direction. They're the dominant error bars in this particular case. Now, that's a simple way of adding error bars in terms of basically using your judgment and deciding how big you think the errors are. In this experiment, doing so was fairly straightforward. We were simply thinking about how accurately we could measure the height and how accurately we could drop from a given height. We were also thinking carefully about how accurately we could time the drop. But in some experiments it's not quite so straightforward judging how big the errors are. One other way in which you can do it is by looking at the various repeats. If we look at each of the readings in each of the columns, you'll see that they're not the same, and by looking at these readings we can quickly judge how big the uncertainty is. Now, one way in which you can get Excel to do this automatically is to create another column in your table. This column I'm going to call uncertainty. Now, the uncertainty in data, roughly speaking, is equal to the biggest value you have minus the smallest value, there we go, divided by 2. Now, a formula I can use in order to get Excel to do that is as follows. What we say is that we want the uncertainty to be equal to the maximum. We now open brackets and we select the 3 sets of readings and then close brackets. We want to subtract from that the minimum from those same 3 readings, so I'll highlight them again. And then I want to divide all of that by 2. Now I'm going to have to add a couple more brackets around the whole thing here in order to do that. And when I enter, that gives me my uncertainty. And once again, I can drag that down. Now, most of these uncertainties, you will see, are actually very close to the uncertainty that I judged above. But they are, as we've said earlier, displayed to an inappropriate number of significant figures. So I'm going to format these cells, and I'm going to ask Excel to display them as numbers to 1 decimal place. There we go. Now, you'll notice in this case, my uncertainties don't actually all have the same value, whereas on my chart I previously told it just to use a standard uncertainty of plus or minus 1. In this case, the uncertainties do vary, reflecting varying degrees of timing success when it came to the experiment. So if I go back to the chart, there is a way of getting it to use those values I've just calculated. What I'm going to do is right click on one of the points again and go back to Format Data Series, and now if I go to my error bars, instead of using fixed value, I'm now going to use custom errors. Now, if I click on this button here to the right of the first box, it allows me to select the column that I've just created. And what this means is that it will use these values now as the customised uncertainty for each particular point. To enter the values, there's a little enter button here on this box on the right hand side. If I click that, those values are now entered in the spreadsheet, and that's for my plus error bar. I now want to do the same for the minus error bar, so I'm going to choose exactly the same values again, so that the plus and minus errors are the same. So you'll see we have our custom errors, both is selected, and if I click OK, you will see that we do indeed have different sized error bars for each of the points.